circuit. So what is a half order circuit? It is nothing but a combinational logic circuit which is used for 2-bit addition. So for binary addition we require adder circuit. So there are two types of adder circuit. One is your half adder and second one is your full adder. For 2-bit addition we require half adder. For 3-bit addition we require full adder. So again, what is a combinational logic circuit? Combination means that the output is a combination of input variables. So whatever we are getting the output here, that is the combination of inputs in case of your combinational logic circuit. So half adder is nothing but a digital circuit used for addition of two single bits. So let the two bits are A and B. So you are having two inputs here, only two inputs A and B. So these are your inputs to your half adder circuit, and what are the possible outputs here? So you are having two outputs of a adder circuit. One is your sum, second one is your carry. So whenever we are adding two single bits, we are getting two outputs. One is your sum and second one is your carry. So that can be explained by using your truth table. So in truth table, we represent your inputs and outputs. So what are the inputs here? A and B, and the outputs are sum and carry. So for 2-bit addition, what are the possible combinations? So it is a single bit addition, that means A value can be 0 or 1. B is a single bit, that means B values also can be 0 or 1. So what are the possible combinations? That may be either 0 0, 0 1, 1 0 or 1. So these are the possible inputs, and for sum and carry we need to add these two bits. So for adding 0 and 0, the sum value will be 0 and there is no carry bit here. Simple, these are addition of binary values 0 and 1. For 0 and 1, the sum value is 1 and the carry value is 0. For adding 1 and 0, we get the output here, sum output is 1 and the carry value is 0. Similar way, whenever we are adding 1 plus 1, that means when 1 plus 1 is added, that means the sum value is 0 and carry value is equals to 1. So that means the sum value here is 0 and carry value is equals to 1. So from the truth table we can get the output expression of sum and carry. So what is the sum expression from this truth table? So this is the sum column. Here we are getting two ones here. For this one, the output value is 0 1, and for second one, the output input value is 1 and 0. So what is the sum expression? From this truth table we can write down the sum expression, that is A by B plus A B1. Similar way you can calculate the carry output here. So what is the carry expression from the truth table? So you are getting a single 1 here. So whenever this output is 1, at that time the input variables are 1 and 1. That means the carry output expression is A dot B. So carry output equals to A dot B. So these are the output expression of your half adder circuit. Next, how we can design the half adder circuit using logic gates. So this can be designed by circuit diagram. So we are having two inputs. So write down the inputs here, A and B. The output expression sum is equals to a bar b plus a b bar, that is equals to a XOR b. This is the expression for XOR gate, a bar b plus a b bar. So we can draw a XOR gate and the output of this XOR gate is equals to sum expression a bar b plus a b bar. Then what is the carry expression? Carry out expression is equals to a dot b. So we need a AND gate here where the inputs are A and B. So from this circuit we can take the connection from A and B, then pass through a AND gate where the output is equals to A dot B. So this is the circuit diagram, this is the truth table, and this is the block diagram of a half adder circuit. So in case of a half adder we need two inputs, two single bit inputs, and we are getting two outputs, sum and carry. And what are possible combinations of input and output that can be seen from this truth table. And from this truth table we can get the output expression of sum and carry. What is the output expression of sum? That is A XOR B. And what is the output expression of carry? That is A dot B. And the output expression can be designed by using circuit diagram using logic gates. So this is the circuit diagram of half adder circuit where the sum expression is equals to A XOR B and the carry output expression is equals to A dot B.